Okay, so we are looking at employees have been working very hard and it's time to give them a raise. The boss is trying to decide if she should give everyone $10, so add $10 per hour, or double everyone's wage, multiply by 2. Okay? Yeah, I'd be about that. So we're going to copy the probability from yesterday's lesson onto this little table. I'll help you do that. I will play nice. Okay, so that's going to be 3 divided by 30, 6 divided by 30, 7 divided by 30, 10 divided by 30, 3 divided by 30, and 1 divided by 30.
The answer is out of 28 though?
No, that was the previous one. Because I said on that second lesson, I said majority of you don't have a job. So, all right. Okay, so how do we find the mean and the standard deviation of these? How do we find the mean and the standard deviation of this? Okay, so go ahead and take a moment. Go ahead and find the mean and the standard deviation. Okay, so just a reminder, if you need to create a table, you turn on your calculator, you create a new document, you hit option 4, which adds lists and spreadsheets. You're going to name your data at the very, very top. Don't use any numbers on that. And then you're going to enter the values. So that's going to be, for our table, you're going to have 3 1s, 6 5s, 7 7s, 10 10s, 3 15s, and 1 25. Okay, take a moment, do that. And when you do, you should have gotten 8.40 for your mean. That's your mu, remember? And then you're going to get 4.76, which is going to be your standard deviation. Okay, if you did not get those numbers, you need to try it or turn to a neighbor, see if they got it. They got it. Ask them how they did it. Okay, yep. All right, so bless you. Now we're going to draw the bar graph, okay, the histogram. So on here, I'm sorry, just bar graph. So on here, if we have 1, it's going to have a probability of 3 out of 30. So we're just going to label these going up by 2s. Plus, or, okay. So at $1, we had 3 out of 30. And thank you, lines. At $5, we have 6 out of 30. At 7, we had 7 out of 30. So it's got gaps, remember? Because we don't have like $2 bill, we don't have $3 bill. Okay. 10 is going to be 10 out of 30. Okay, 15 is going to be 3 out of 30. And then 25 is going to be 1 out of 30. Okay, I'll give you a. All right. So to make a decision about what raise should be given, calculate the new mean and the standard deviation using technology. Okay, so the old wage was $1. If we added $10 per hour to the old wage for all employees, this is what we would get. We would get 11, 15, 17, 20, 25, 35. Okay, the probability is still going to stay the same because everybody's just increasing by $10, right? Okay, so go and fill that in. 7 out of 30, 10 out of 30, 3 out of 30, 1 out of 30. Okay, so all we did is we took the old wage, we added $10 to it, and we used the same probability. Now, what's going to happen to the mean on that one? It's gonna increase by 10, so it's gonna be 1840. That was mu plus 10. What's gonna happen with the standard deviation? It's not gonna change. So 4.76 is the standard deviation. On the graph, it's gonna look the exact same. It's gonna have the same shape. Only difference is the numbers are gonna just be a little different down here. Okay, so you'll still have one here. Oop, that's too far. We need a label first. 2, 4, 6, 8, 10. We would have one here at 3 out of 30. And then we would have a 6 out of 30 here. And then we would have a 7 out of 30 here. Are there any numbers that are in between 1 to 5 that we're talking about? No. So there's a gap in between. So for 20, we're going to have 10. What's more? For 25, we're going to have 3 out of 30. And then for 35, we're going to have 1 out of 30. Yes, thank you, bar graph. All right, so how did adding a constant affect the mean and the standard deviation? So we already talked about it. Mean goes up by 10. Standard deviation stays the same. So, thank you. No, you do it all the time. All right, so on the probability, it's still going to remain the same. Okay, so you're going to say 3 out of 30, and you're going to say 6 out of 30, and you're going to say 7 out of 30, and you're going to say 10 out of 30, 3 out of 30, and 1 out of 30. You're going to have the same shape on this one. Okay. But now, what's going to be the actual mean now? It'll be a lot different. Go ahead. It'd be twice the old mean. It would be twice the old mean. Okay. And that's 2 times mu. Stop it. All right. What about the standard deviation? What are we going to do there? Multiply by 2. So that's going to be 9.52. All right. So how did this affect the mean and the standard deviation? Both were multiplied by 2. Yes. All right, so which option would you prefer? Why? But I make more money on, like, if I'm making $1, I make $1, I'm on option 1, right? Okay, so I would want option 1 if I was making $1, $5, or $7. I would want option 2 if I was making 15, 25. 10 really isn't impacted, right?
Right.
They could go either way. Yeah. Okay.
More for relating.
So once you flip, what we talked about is if we added or subtracted a constant, then how did it impact the shape? How did it impact the center? How did it impact the variability? Okay, so the shape, it remained the same. The center, you would add or subtract whatever the constant is. And the variability remain the same. When we multiply or divide by a constant, the shape remained the same. The center, we either multiplied or divide by it. And the variability, we either multiply or divide by it. Okay, talk to me on what about the types of variability. What do we have? What's the first one you know? Range. Okay, what else? Standard deviation. We've got IQR as well. And then we're now going to start talking about something called variance. Okay, when we look at variance for these, you're actually going to multiply, divide, and then you're going to actually multiply, divide by c squared. So whatever your constant is squared. We're going to talk about that more in the next lesson. So don't freak out about it, but it is there. Okay. All right. So go ahead and take a moment. I want you to work through problems 1 through 4. And please try these problems. Don't just sit there and do nothing. Don't wait for me to put answers on the board. Okay. Go ahead and try those problems. I need you to practice with your calculator. Okay. All right, go ahead and get started on those. Okay, so let X represent the number of billionaires in a randomly selected state. Based on the current records, the probability distribution is as follows. The random variable X has a mean of 12.68 and a standard deviation of 29.02. Suppose a law is passed requiring each billionaire to pay a $7,000 tax to their state. Let Y represent the tax money received by a randomly selected state. For a state that has 9 billionaires, how much tax money would they receive? So each billionaire has to pay 7,000, right? Multiply it by 9. Okay, yeah. Plus. Okay. Okay. Consider the graph of the probability distribution of X and a separate graph of the probability of the distribution of Y. How would their shapes compare? Yep. I can't hear you, sorry.
The shape would be the same, but the center and standard deviation would vary by a factor of 7,000.
What would the shape be? All right. Okay, skewed right. Okay. Okay. So the probabilities would be the same, and their shapes would be the same, but they would be skewed right. Okay. All right. How would you find the mean and the standard deviation of Y? Now remember, Y is representing this crazy thing where they pay $7,000 to the tax, right? So to find the mean, they gave us the original. So all we're going to do is we're going to say the mu of Y is equal to 7,000 times mu of X. So 7,000 times 12.68. Yeah. When you do that, that's going to give you 88,760. For our standard deviation of Y, you're going to take 7,000 and you're going to multiply it by the standard deviation. of the original. So 7,000 times 29.02. And so that's going to give me 203,140. Go ahead and take a moment. Right. So the shape is going to continue to be the same. Okay, so skewed right. Okay. Then the mean on this one. So this tells us that they're losing $20,000, right? Okay, so the mean is going to be M sub n is equal to mu of y minus 20,000, right? So that means that from the previous problem, we found 88,760 minus 20,000. That's going to give us 68,760. For the standard deviation, since it's subtracting, remember our standard deviation stays the same from what it has been. So it's going to be equal to the standard deviation of the previous problem, which was 203,140. Okay, so these are those transformations that you learned back in like geometry or algebra. It's the same concept. If you multiply, then you're going to multiply by the mean and the standard deviation. If you are adding or subtracting, then you're just going to move the mean, keep the standard deviation. Good? Okay. On this next part, I need you to have your calculator out because I'm going to teach you how to calculate based off of the probability and actually putting in a list. So go ahead and make sure you got a calculator out. I will eventually add this to the how to calculate sheets. We're going to watch this video because I can't project my calculator right now. All right, so this is how you don't have this on your page, okay? This is how we put it into our calculator with probabilities versus having just like, you know, hey, there were 3 of this number, there were 4 of this number. This will kind of make it a little bit easier. You can also go back and remember how we said like 3 out of 30, you can turn those into probability decimals and do it this way as well. Okay, so here it is. Okay. All right, so go ahead and hit new file, so doc, file, new, okay? And then you can follow along. Everybody okay so far? Okay. Okay, so this is the only difference. That frequency is going to change to probability. Okay, so instead of it being like a one iteration per number, it's going to be the probability of that. Okay, did everybody hear that? So standard deviation is that sigma sub x. Variance, you just take this number and you square it. Okay, so that takes us into this next lesson. Okay, so how much will you make next year? After much thought, your boss has finally decided on permanent employee wages, which are randomly assigned using the probability distribution below. Additionally, at the end of the year, she will give her employees an hourly raise. The pay raises are assigned randomly according to the probability distribution. Assume X and Y are independent. Okay, so go ahead and take a moment. Go ahead and put this list in your calculator. Tell me what the mean, the standard deviation, and the variance is. Variance is standard deviation squared. Okay, so take a second, find those. So you should have gotten 11.85. Okay, you should have gotten 2.22. And then you should have gotten 4.93. Okay. Just as a side note, for your standard deviation, don't round it and then square it. Try to get as many decimals as you can before you square it, because that does change it a little bit. Okay. All right, go ahead and do it for the next one as well. Okay. Again, we want to make sure that you have that down so you're not fumbling around on the AP. All right. So you should have gotten 1.6. And then JK, 1.6. And then you should have gotten 0.92 and 0.84. Questions on that? Okay. All right. So the next question says, let N equal the new hourly wage for the upcoming year, X plus Y. What are the possible new hourly wages for the new year? What are the new possible wages for the upcoming year? Okay, so again, X plus Y. This is X, this is Y. So what's 9 plus 1? Okay. What's 12 plus 1? What's 15 plus 1? Okay. Then what's 9 plus 3? So everybody see how I got that? I took my X options, I added them to my Y options. And normally you want to make a list. Like if they ask you for a list of things, you want to do it from least to greatest. Okay. What is the probability of getting a $9 wage and a $1 raise? Okay, so let's use the notation. Hold on, no. Okay, so what is the probability of getting 9 and 1? Okay, well, what's the probability of getting 9? 0.3. What's the probability of 1? Okay, so we're going to multiply 0.3 times 0.7, and that's going to give me 0.21. Okay, what's the probability of getting a $9 wage and a $3 raise? Okay, make sure that we use our notation. So probability of getting 9, 3. Probability of getting 3, 0.3. And that's going to be 0.09. Okay, so I want you to take a moment and I want you to fill in this table for our options of $10, $12, $13, $15, $16, and $18. Okay, we did this one already. That was from this. We did this one already. That was from that. Okay, can you fill in the probabilities for 13? Really quick, are X and Y independent of each other? It says what? Okay. All right, so when you found these probabilities, you should have gotten 0.315. Yeah, 0.135 and 0.175 and 0.075. Everybody understand how I got there? Okay. So now we're going to find the mean, the standard deviation, and the variance. Okay. Now you can do this by actually like plugging it into your calculator. Okay. Or what you can do is take your X and your Y's mean and standard deviation and then kind of manipulate it from there. So for instance, the mean for this one is going to be the combination of 11.85, which was from that first box, plus 1.6, which is going to give me 13.45. How do we find the standard deviation? How do we find the standard deviation? Okay, what if we added 2.22 plus 0.92? So would this work for this one? No? Okay, so what can we do? What can we do? We can plug it back into our calculator. Make your list. So take that last table, make your list, and pull the mean, the standard deviation, and the variance. Yeah, babe. What does it say on there? 5.76? Yes. Yeah. So I got 13.45 for the mean. For the standard deviation, I got 2.40. Okay. And then for the variance, okay, if you scroll all the way down to the bottom, then it tells you the variance. Okay. So that's going to give me 5.77. Okay. Questions? Round it to decimal. Yeah. Okay, now here's the part that confuses a lot of people because we like to use notation in stats. So don't get tripped up by all these little Greek symbols. Okay, if I was finding mean of n, then I'm going to find the mean of x and add it to the mean of y. Okay, this next one looks a little crazy. It's not my fault. So on the next one, you're going to have the standard deviation of x squared plus the standard deviation of y squared, and you're going to take the square root of it. On your formula sheet, you were given this one. And then for variance, that means that we're going to do the standard deviation of x squared plus the standard deviation of y squared. And really, it's just your standard deviation squared. Okay? We okay? Again, it looks crazy. It's not that bad. Okay, let's do the quick notes really quick. Quick. Okay, combining random variables. So combining random variables. We already talked about this on the front. If you're going to add means, then that means that you're just going to find the mean of each and add them together. For standard deviation, remember, we're going to do this fancy formula of square root of standard deviation of x plus the standard deviation of y. I want you to note that one does not simply add standard deviation. I've seen Lord of the Rings. Yeah. One does not simply walk into Mordor, nor does one simply add the standard deviation. So that's not how it works. Okay? That normal distribution stuff comes back in this unit. We didn't see a whole lot of this, but you're going to use the formulas to find. So use formulas to find mu and standard deviation. These are the formulas for it. Okay. So just a reminder, you've got your bell curve. Your mu is in the middle. Whatever you're solving for is your x value. Remember, it's also listed on the side. It'll have mu and standard deviation inside those parentheses. And another reminder, to find your z-score, you're going to do whatever value you're finding minus your mu divided by the standard deviation. Okay, this isn't easy unless you practice. Okay, so what I want you to do is I want you to go ahead and try A, B, and C. Okay, go ahead and take a look at those, read them over. Okay, and then we're going to talk about them. Okay.